Okay, so we've got a test here being carried out about if a baby has a disease or not. It's been trials. And then when you carry out the test, you're either getting a positive or negative. So it's a sequence of two things here is happening. So the diagram that helps us here is a tree diagram. Okay, so the first decision is whether the baby has the disease or not. So my first branch is showing the disease or not disease, and then the second thing then is whether the test is positive or not. So the choice here, positive or negative, and the same choice comes out if it doesn't have the disease. So the test, either the test comes out positive or it doesn't come out positive. Right. So 1% have the disease. So 1% as a decimal is 0.01. So 0.01 is the chances baby has the disease. So that's 0.99. Because these two branches have to add up to whole one. Baby does not have the disease. Now then, there's a positive result when the baby has the disease. So that's 0.9. So this branch will be 0.1. You also have to add up to 1. And if baby doesn't have the disease, there's a positive, still a positive result for 0.05, and this will be 0.95. So there's the information represented on a tree diagram. And what I want is, I want probably the test gives a positive result. So I want the probability of a positive result. Now to get a positive result, it can happen two ways. Either has the disease and positive, or doesn't have the disease and positive. So it's going to be 0.01 times 0.9, or 0.01 times 0.9, or 0.99 times 0.05. And calculating that, and that's giving me an answer of 0.0585. Part B, calculate the probability that the baby does not have the disease given that the positive result is obtained. So there's a given there, it's a conditional probability. So open bracket out, line there is the condition. Now what I'm given gets written after the line, so I'm given there's a positive result. And what I want to find the probability of comes to the left of the line. I want to find the probability it does not have the disease. And then to open this out, I replace the line with the word and. So it's the probability does not have the disease and positive result over, and it's the probability of what I'm given, so it's the second part on the bottom line. So doesn't have the disease and positive. On the tree diagram, that's this root. Doesn't have the disease and positive. So top line is 0.99 times 0.05 over the probability of a positive, and I've already calculated that in the first part. That's 0.0585. I'm calculating that, use the fraction button. 0.99 times 0.05 on top, and on the bottom is 0.0585. And that is 0.846153. Then part B, so that was part A, part 1, part 2, and part B It says comment on the weakness of this test. So what we found now in the second part is if the baby doesn't have the disease, okay, so we got a positive result, but the baby doesn't have the disease, and we see this is a high probability. If I put into percentage, that's what we're saying is 84.6%, okay, of those where a positive result is obtained, the baby doesn't have the disease. So that's the reason why it's just such a poor test. We'd want this percentage to be very low. So 84.6%, okay, of where the baby does not have the disease, but the positive result is given. Obtained. Okay, that is far too high, isn't it? Percentage too high. You would expect that to be quite low.